Hello, Norma. Welcome back. Yeah. Next Tuesday. We'll do next Tuesday. Hi, Norma. I can give you one more day for the exam. I mean, okay, guys, we'll start our lesson. So I hope others will join us. So today we are going to talk about graphs of functions. That's the first topic, 5.3. So we'll see how to graph functions by plotting points, just figuring out points, and we will graph function by plotting points. That's the first topic. So we are going to determine the graph of function, and after that, the second topic will be to understand and analyze linear function and using slope and intercepts. So those concepts will be introduced in the next topic. So the first topic is basically evaluating function and finding some points and plot those points, connect those points and plotting a graph. So for this lesson, I am going to graph linear function and quadratic function. Okay. So now that we introduced Cartesian coordinate in 5.2 and 5.1, guys remember last time? So we know the rectangular coordinate system. So we are ready to sketch graph of a function in order to get two-dimensional picture. So the graphs will give you different information about the function, whether it is increasing function or decreasing function, and also it shows you the shape of the function. So the graph of a function allows us to see the behavior and properties of the function. We better understand functions if we see them in graphs rather than in function notation. That's why we are graphing functions. Okay. Now, graphs of a function, the graph of a function consists of all points whose coordinate x, y satisfy the function. Whatever given function you have y as a function of x, any x value you pick should give you a certain y value, a unique y value. So those ordered pairs will give you the graph of the function. So if you have as many ordered pairs as you can, and if you connect those ordered pairs, that's the graph of the function. So today we are going to see linear function. So if you have linear function, that means it's straight line. Linear functions are straight line. So linear functions, you need only 2 points. Okay. If you have 2 points, connect those points, you have your graph. And quadratic function or any curve or curved function, you need at least 3. Okay, if the function is curved, you need at least 3 points. Okay, so first we'll see how to graph linear function, then we'll see how to graph quadratic function by plotting points. basically we are going to evaluate functions, find the y value. So because the x is independent function, we can pick any x value. Then we find the corresponding y value and we plot those points, and finally we connect them. That's basically what graphing is. Now let's see the procedure on graphing. So procedure for creating a graph. First, create a table of ordered pairs. So you create a table, you pick arbitrary x values, but you have to be, usually we use numbers from like -2, -1, 0, 1, and 2. We are interested to see the behavior of the graph around 0. So usually we pick points like this. Then once you choose x, you will find y from the function f of x. So you will find f of -2, f of -1, 0, f of 1, f of 2. So for linear function, you don't have to do all 5. Just 2, you are done. Okay. Now, the next thing you do is plot the ordered pairs on the graphing paper. So you just plot the ordered pairs. At -2, let's say you get 10. So you plot -2, 10, like that. After that, connect the points. Just join the points from left to right using smooth curve. You have to use smooth curve and connect the points. That way you have your graph. Okay. So this is the procedure on graphing linear function. Okay, now linear functions are functions in the form of f of x equals ax plus b. If you see a function in this form with x, it's called linear function. Linear functions are functions of the form. It can be written in this form. That's basically what it is. It can be in different form, but we can reduce it and write it in this format. So any function which can be written in this format is called linear function. It doesn't have radical, doesn't have square or any power. It's just a times x plus b. Okay, that's called linear function. So where a and b are constants, they are constant numbers. It's called linear because the graph is straight line. So linear means a straight line. Linear. We call it linear because the graph is a straight line. We will graph this function by point plotting. So first we see how to graph them by point plotting. In the next topic, we're going to see how to graph them by using slope and intercepts. Okay, and I'll explain what those are. Now we have example here. Before I start my example, do you guys have any question? Any question here? Okay, if you don't have any question now, let's go to graphing. So if you see this function, this is linear function because I have 2x plus 3, which -2x plus 3, which means a is -2. Now to graph functions like this, we pick x values. So for now, I'll show you 5 x values, but we don't need 5 values for linear function. We need only 2 values. So we have x and y. So let's choose these points, -2, -1, 0, 1, and 2. That's enough. More than enough. So what you have to do is find f of -2, f of -1, f of 0, f of 1, and f of 2. So the way we do it is just plug in -2 into the function. So it becomes -2 times -2 plus 3, which is -2 times -2 is 4, plus 3 equals 7. So the first number here is 7. Just plug in the number, the x value you have. So we choose those x values and evaluate the y value. So the second one here, -2 times -1 plus 3, which is 2 plus 3, which equals 5. So the number is decreasing by 5. Can clearly see it is decreasing by 2, I mean 7 to 5. At 0, you have -2 times 0 plus 3. -2 times 0 is 0 plus 3 equals 3. So we have 5 here, we have 3 here. The next one is f of 1. Just plug in 1 into negative 2 times 1 because we have negative 2x. We are plugging numbers here, okay? Plus 3, which is negative 2 plus 3, which equals 1. So we have 1 here. The next one is negative 2 times 2 plus 3, just f of 2. Negative 2 times 2 is negative 4, plus 3 will be negative 1. So we have now 5 ordered pairs. At negative 2, we have 7. So negative 2, we have 7. This is negative to 7. At negative 1, we have 5. At 0, we have 3. At 1, we have 1. At 2, we have negative 1. So once you have all these points, the next step is to connect them and graph a smooth curve from left to right. That's it. That's your graph. Now, if you see here, because this is a straight line, we don't need all these 5 points. You need only 2 points. Okay? Next time, we'll just graph 2 points, and that's the graph. Okay, you don't have to plot all these 5 points. Any question on this example? Any question? Any question? Okay, now let's try the second example, and I think it will be more clear when we do the second example. Now we have this function f of x equals 3x plus 2, and it asks you to graph the function by plotting points. So I'll give you the table x, y. You need only 2 points. So I want you to find the y value for 0 and 1. So what is f of 0? What is f of 1? What is f of 0? And what is f of 1? Just plug in 0 into the function and plug in 1 into the function. Two and 5, exactly. Yes, that's correct. So all we have to do is just plug in 0 for the first one. So 3 times 0 plus 2, which is 0 plus 2, which equals 2. So the first one is 2. So at 0 it is 2. Then you plug in 1. So 3 times 1 plus 2, which is 3 plus 2, which is 5. Okay. So we have 2 ordered pairs. At 0, it is 2. At 1, it is 5. It is going this way. Just connect the graph, and that's your graph. Very simple. So graphing linear function is really simple. All you have to do is find 2 points. You can use 0 and 1 always. You can use 0 and 1 and plug into the function. It will give you some values. So connect those values, and that's it. You are done with the graph of the function. Any question? Oh, it's fine, Jasmine. Okay, guys, next question here is graphing again, but this one is quadratic function. So a quadratic function is a function in the form ax squared plus bx plus c. F of x equals ax squared plus bx plus c. If you have a function in this form, it's called quadratic function. Okay. So the quadratic function has something called vertex. So let me write it down here. Vertex. It is the turning point. Okay. Turning point. And axis of symmetry, it's a line passing through the vertex, and that line is x equals negative b over 2a, where a and b comes from the function. You see the function f of x equals ax squared plus bx plus c. Those parameters a, b, and c will determine the turning point and the axis of symmetry. So the x value for the vertex comes from x equals negative b over 2a. Now let me explain the graphs. Oh, sorry. Let me explain the graph here. Now, if you have, sometimes it will open up. The graph will open up if a is greater than 0. If a is positive, the leading coefficient in front of x squared, the number in front of x squared, if it is greater than 0, it will open up. Sometimes it will open down, okay? Like this. Up and down. If a is less than 0. If a is negative, it will open down. So a positive. If a is positive, it will open up. If a is negative, it will open down. Opens down. Okay. So this is the first information. Now the next information is the vertex. That's the turning point. So I'm going to use this for the vertex here. This is called the vertex. So the coordinate for the vertex, the x coordinate is negative b over 2a. So the negative is outside. Sorry, it's negative somewhere outside. Comma f of negative b over 2a. So you find the corresponding y value by using negative b over 2a. That gives you the vertex of the function or the turning point. And the axis of symmetry is a vertical line which divides the graph into two equal parts. It's like a mirror image of each other. Okay. The graph becomes its mirror image. That is why it's called axis of symmetry. X equals negative b over 2a. And this is how we graph quadratic functions. Find the vertex, that means the x value for the vertex, and make a table by finding additional 2 points. So to find those additional 2 points, we'll go 1 to the down. So we subtract 1 and we add 1. So we go 1 up, 1 down. Then you have 3 points. Find all the function value for those 3 points and connect them, and you have your curve or parabol. So let's see how we can do that in the next slide. So sorry about that. So this is supposed to be in the previous slide. It's okay. I'll talk about this before we complete. This one is fine. So we will move. I will talk about this later. So let's move to graphing. Sorry, there was some misplaced slide. That's why. Okay, now f of x is given in this function. F of x is given as negative x squared minus 4x plus 1. So compare this to the general form of the quadratic formula. F of x equals ax squared plus bx plus c, and find a is how much? No, we don't need it. And what is b? And what is c? Okay. After we found a, b, and c, we use x equals negative b over 2a to find the x coordinate for the vertex. Okay. Now tell me what is a, what is b, and what is c. What is a, what is b, and what is c? Just compare the two functions. If you don't see any number in front of the function or the variable, it means there is one. So if you have x, technically it is 1x. Okay. So with that, find a, b, and c first. Anyone? What is a, what is b? Just compare the two functions. A equals 2. Okay, what is b? Three. No, let me show you. Just let me circle it, and if we can see it. Can you guys see that? So we don't have number in front of x squared, so that technically that is -1. We have a negative, so it's -1. B is -4 here, and C is 1. Okay, that's how you figure out A, B, and C. Now, once you find A, B, and C, you have to find x equals -b over 2a. So that means you have a negative, b is -4 over 2 times a, 2 times -1, a is -1. Okay, so we have a negative outside, don't forget that negative. -4 over -2. So -4 divided by -2 is +2. So this will cancel out. So we have 4 divided by 2 is 2. So we have -2. So the x for the vertex is -2. So we locate that in the middle. So locate that in the middle. Then subtract 1, you'll have -3. Add 1, you'll have -1. So the middle one is for the vertex always. Okay. Now once you find the x value for the vertex, that means it is the axis of symmetry at -2. So the graph will be symmetrical along this line. Now this is what you do. Find f of -3, f of -2, f of -1. Okay, so just plug in the numbers into the function and find f of -3. That means negative of x squared, so negative of -3 squared minus 4 times -3 plus 1 for -3. So just plug it into the function. So negative of x squared, which is negative of -2 squared for the second one, minus 4 times -2 plus 1. And for the third one, we have negative of -1 squared minus 4 times -1 plus 1. It's just plug in the numbers. After that, just evaluation. So we have negative outside. 3 squared, negative 3 squared is 9. Negative 4 times 3 negative is 12. So negative times a negative is positive. Then we have plus 1. Negative 9 plus 12 is 3. 3 plus 1 would be 4. So at negative 3, y is 4. Then we go to f of negative 2. We have negative outside. Negative 2 squared is 4. We have negative 4 plus 4 times 2 is 8. Negative times a negative will be positive, and plus 1. So negative 4 plus 8 is 4. 4 plus 1 would be 5. So the next number is 5. Next, we go to f of negative 1. So you just plug in negative 1 into the function. Have that. So this comes from the function, okay? If you guys can see at the top here. It comes from this function. Negative x squared, which is in this case negative 1 squared, minus 4x, minus 4 times 4 plus 1. Okay, so negative 1 squared is 1. So we have negative 1 plus 4 plus 1. Negative 1 plus 4 is 3, plus 1 would be 4. So we have 4, 5, and 4. So at negative 3, it is 4. 1, 2, 3, 4. At negative 2, it is 5. Let me use different colors so that you can see. Here, and here, and here. Then you connect those 3. You have your graph. If you want, you can find the x-intercept, y-intercept. But for now, if you find those 3 points, you are done. So this graph opens down because a is negative. When a is negative, it opens down. When a is positive, it opens up. Any question on this example? Any question? So the vertex, so to answer these questions, so if you are asked for the vertex is the middle line or the turning point. It is at negative 2, 5, the point of turning point. Axis of symmetry of, so axis of symmetry, M should be double, x equals negative 2. That's a line. It's a vertical line. X equals negative 2. Okay. So this is x equals negative. That's called the axis of symmetry. Okay, now I want you to try this and find those 3 points. 2x squared minus 4x. I rearranged the function for you and compare it to f of x equals ax squared plus bx plus c. Find a, find b, find c. Let me give you a, b, and c. A is 2, b is negative 4, c is negative 7. So x equals negative b over 2a. The negative is outside, so it's just negative b over 2a. Now use this and evaluate that value and locate it in the middle. Then find the f of, so give me this value now. Give me the x for the vertex. Okay, give me the x for the vertex first. You have to rearrange it. Here you go. So if you see the function, the a is in front of x squared. So the x squared is, the quadratic term is 2x squared. Now a is always the one with in front of x squared. So you have to rearrange the equation. So this equation needed rearranging. So you have to write it in standard form. That's the standard form, where you have 2x squared minus 4x minus 7. So this is not the standard form, okay? A is always the number in front of x squared, B is the number in front of x, and C is the constant number. Now give me x now by using the formula. Okay guys, what is x for the axis of symmetry, which is negative b over 2a? Just plug in b and a and evaluate the expression. That's all you have to do. Very good, Jasmine. Different answer. -1, okay. Let's suppose negatives. Okay, let's see. So you plug, there is a negative outside, don't forget that. This expression always has negative outside. The negative b b is -4 over 2 times a, which is 2. So we have negative of -4 over 4, which is negative of -1. So negative times a negative makes it positive. So we have 1. So make sure you have the negative outside, okay? I know sometimes these negatives, when they are they repeats, we make a mistake. So for this problem, x is -1. So we locate, sorry, 1. I mean not -1, 1. So the vertex is located at x equals 1. Then we will do 1 less, we go to 0, and 1 up, we go to 2. Then we find f of 0, f of 1, and f of 2. So f of 0 is 2 times 0 squared minus 4 times 0. Just plug in 0 into the function, minus 7. So which is 0 minus 0 minus 7, which equals -7. So at 0, it is -7. F of 1, just plug in 1 into the function, 2 times 1 squared minus 4 times 1 minus 7. So 2 times 1 squared is 2 minus 4 minus 7. So this will give you -2 minus 7, which is -9. So the vertex is at 1, -9. And f of 2, 2 times 2 squared minus 4 times 2 minus 7. So 2 times 2 squared is 4. 4 times 2 will be 8. Minus 4 times 2, which is 8 again, minus 7. So 8 minus 8 is 0. Then we have -7. So we have all the 3 points. So the axis of symmetry is at 1. So you have a vertical line at 1 like that. axis of symmetry is the x value on the vertex, which is x equals 1, and the vertex is at 1 comma negative 9. So you locate that first. 1 comma negative 9 is right here. Then we have 0, negative 7, and 2, negative 7. So this would be your graph. Okay. That's it. If you have those 3 points, just connect them and make a U-turn like that. And that's your parabola. It's a long process, but it's the formula, Jasmine. It's the formula. The formula says negative b over 2a. It's a given formula. The negative is always from the formula. Negative b over 2a. You see, the negative is always there. So that's the formula you're going to use. Okay, so we are done with this unit. Now let's go to, I think with this topic, not unit. We are still on unit 5. And now let's go to the next example. Sorry, the next topic. So in the next topic, we are going to graph linear functions. That's our objective. Graph linear function. So we'll learn how to find the slope of a line using ordered pairs. We'll learn what a slope is. Describe the slope of a horizontal and vertical line. So we'll talk about that also. Sorry. Give me a moment. Okay, good. We're good. So we'll talk about the slope of using ordered pairs. Describe the slope of a horizontal and vertical line. Find x and y intercepts. We'll talk about finding x-intercept, y-intercept. Then find the slope of y-intercept, the slope and y-intercept from a linear equation, and find the equation of a horizontal and vertical line. So that's basically what we are going to do. Okay. Now let's start here. Now in 5.3, that is the previous topic, we graphed linear function by point plot. So you just figure out x, y using table and we plot them, and that is how we graph functions. In this section, we are going to explore how to graph a linear function using the slope of the line. And basically what a slope means is slope describes the steepness of a line, and it is measured as the ratio between vertical change, rise, to horizontal change. So the slope describes how fast the function is increasing or decreasing. So it's the rate of change. If you are given a function like this, what the slope says is how much does the function changes if there is a change in y. So let's say change in y represented by this change in x here. How much change in y do you have when you have change in x? So change in y is y2 minus y1. So let's say this is x2. This is x1. This is y1. This is y2. So change in y is y2 minus y1. Change in x is x2 minus x1. Okay. So the slope says how much we change vertically when we change horizontally. So what amount does the y value changes if x changes in a certain value? Okay. That is called the slope of a line. So you have vertical change, that means rise, how much it draws, like that vertical change. over how much it has run. This run, horizontal is run, vertical is rise. So the formula is this. I want you to keep this formula. So y1, x1 represent points. So this one, y1 means 0.1. x1, y1 means 0.1, the first point. It's just to represent you have 0.1, and this one is 0.2. Okay, so if you know 0.1 and 0.2, you can easily find the slope, and that's what we are going to do next. Okay, we have this example. So the first example is simple because we are given the rise and the run. So the slope m is rise over run. So the rise is 16, the run is 4. So 16 over 4 is 4. So the slope is 4. Straightforward. So this example we have given the rise and the run, and we are asked to find the slope. And that's the value, which is 4. Now, if you are given 2 points, this is what you have to do. So you have to designate which one is 0.1, which one is 0.2. So if you are given 2 points like 4,9 and negative 3,7, so I would say 0.1 is the first one. That means x1 and y1 are 4,9. 0.1. So x1 is 4, y1 is 9. 0.2 is the second one. You can do vice versa, but it's better always to stick to say the first one is 0.1, the second one is 0.2. So when you have 0.2, this becomes x2, this becomes y2. Okay, now the slope m is y2 minus y1, change in y, over x2 minus x1, change in x. So our y2 here is negative 7. Just plug in the numbers. Y2 is negative 7. X1 or y1 is negative, 9, divided by x2 is negative 3, and x1 is 4. Just plug in the numbers. So negative 7 minus 9 is negative 16. Negative 3 minus 4 is negative 7. So negative divided by negative is positive. So I have 16 over 7. So the slope is 16 over 7. Any question on this example? So this is finding slope from a given 2 points. So we have 2 ordered pairs. So you have to designate which one is 0.1, which one is 0.2. You can interchange it. It doesn't matter. So you can say 0.1 is negative 3, negative 7. 0.2 is negative 1 and negative, 4 and 9. You still get the same answer. So the slope will be 16 over 7. Any question? Okay, Norma. Yeah, I have the video, so I'll post it on Canvas. I'll try to post it on Canvas. I think you can access it on Big Blue Button. If not, I'll try to post it on Canvas. Okay, now I want you to try this code. Okay, now try this question. Everyone try. First try the first one. So I'll give you, find the slope m. Okay, so let me designate the points, but so x1, y1 will be 3, negative 3. x2, y2 will be negative 6, 3. Find the slope m equals y2 minus y1 over x2 minus x1. Just plug in the numbers and find the slope. Okay. Okay, now try, everyone try this. Got 0. Interesting. Okay, any different answer? So we have 0. So you have to simplify your numbers. Good. Okay, so we have -2. Do you have any different answer? So Norma says it is 0. I think you're typing m equals 0. Yeah, that's fine. We got it. Any different answer? I know working with signed numbers is sometimes challenging, but I want you to pay attention to the rules of addition and subtraction we talked about at the beginning of the school year. That's why we studied how to add charged numbers, negative, positive numbers, combined negative and positive numbers. Okay, now let's do this problem. So it seems like we have 0 and -2. So let's see. Now, if you see here, y2 is 3. So y2 is 3 minus y1 is -3. So minus 3 divided by x2 is -6 and x1 is -3. Sorry, 3 minus 3. x2 -6 minus 3, which is x1. So this one minus makes it plus. So it becomes plus at the end. So 3 plus 3 is 6. Over -6 minus 3 is -9. Technically, you are adding two negative signs. So you just add the numbers and keep the sign. So if you reduce this by 3, it becomes -2 over 3. Okay, so that's the correct answer, -2 over 3. Any question on this example? And do you see how I got -2 over 3? Okay, I want you to try the next one. Try the next one. Try the next example and find the slope. What is the slope of the next function? Okay, guys, x1 is -3, y1 is -8, x2 equals 2, y2 equals -8. So m is change in y, which is y2 minus y1 over x2 minus x1. So y2 is -8 minus y1, which is -8, over x2, which is 2, minus -3. 2 minus negative. Minus minus plus. So minus minus becomes plus here, as well as here. So this -8 plus 8 is 0. 2 plus 3 is 5. So 0 over 5 is 0. So this function has a constant y value. So the y value is just -8. Doesn't matter which x value you have, y is -8. So this is called horizontal line. Horizontal line. And horizontal lines have slope equals to 0, m equals 0. Okay. So next we talk about horizontal and vertical lines. Now, vertical and horizontal lines. So when we graph functions, if you get a horizontal line with some constant y value, so this function has a form y equals c. Y equals some constant number. So y is constant. So it doesn't depend on x. For any value of x, you have the same value y. And if you have a vertical line at a certain x value, so let's say x equals c here. Again, this one is x equals c. That means x is constant. So x doesn't depend on y. So it will indefinitely be the same value. So these two kind of functions have different slopes. So for this one, change in y is 0. That means the slope is 0, horizontal line. For this one, change in x equals 0. If change in x is 0, that means the denominator in the slope form is 0. That means the slope is undefined. So the slope will be undefined for vertical line. Horizontal line, the slope will be 0. Okay. Any question about horizontal and vertical line? Okay, now next we'll see how to graph a function by using intercepts. So before I will find and talk about intercepts, let me go back here. So if you have a linear function, so the intercepts are the place where the graph crosses the x-axis as well as the y-axis. So the place where the graph crosses the x-axis is called x-intercept. And the place where the graph crosses the y-axis is called y-intercept. So what is unique about this? This is y, okay? The top is y. So what is unique about these 2 points is on the x-axis, y is 0. So to find the x-intercept, you set y equals to 0. On the x-axis, y is 0. On the y-axis, x is 0. So to find y-intercept, we set x equals to 0. So the intercepts are interesting because one of the value will be 0 in the corresponding either x-intercept or y-intercept. So at x-intercept, y is 0. For y-intercept, x is 0. Okay, so to find x-intercept and y-intercept, if you are given a function like this, to find x-intercept and y-intercept, all you have to do is plug in x equals 0 to find y-intercept, plug in y equals 0 to find x-intercept. So first, let's figure out x-intercept. That means y is 0 on the x-axis. So y is 0. So y equals 0 will be plugged into the function. So you will have 3x plus y, in this case y is 0, equals 3. That means 3x equals 3 and divide by 3, x equals 1. So x equals 1 is the y-intercept. So it's a point when y is 0, x is 1. That's basically what we are saying. That is the x, that's the y-intercept, the x-intercept. I transposed the numbers, sorry guys. We know x is 1, y is 0. X is 1, y is 0. This is the x-intercept. So 1, 0 is right here. The second one is the y-intercept. For the y-intercept, we said x equals 0. Just plug in x equals 0 and find the y value. So can you tell me the y-intercept? Right on the chat. Exactly, Norma. That's right. Excellent. Excellent, Norma. So x is 0. That means 3 times 0 plus y equals 3. So 3 times 0 is 0. So y equals 3. X 0, y 3 will be the y-intercept. Y-intercept. So the y-intercept is at 3 right here. It says y equals 3. So we have 2 points. Once you have 2 points, connect those 2 points, you are done with your graphing. That's it. That's how you graph linear functions. That's the beauty of linear functions. It's easy to graph. All you have to do is figure out those 2 points, you are done. You just draw a straight line and you are done. Any question on this example? So it is a similar question, and I'll give you 5 to 6 minutes, and I want you to tell me the x-intercept as well as the y-intercept. Then we'll graph it together. So next question: graph 5x minus 2y equals 20. So find x-intercept. That means y equals 0. Y-intercept x equals 0. Once you find those two, locate those two, and you graph the function. Yeah. Excellent, Hugo. That was correct from the previous example, I think. Excellent, Norma. That will be the y-intercept when x is 0, y negative 10. Good. X4. Okay, good. Excellent, Abhi. So you have both of them. X4, y negative 10. Very good. So I'll wait for others to answer. Jasmine and Hugo, do you guys have any answer? Okay. Okay, good. So most of you got the correct answer. So for the first one, the x-intercept, we plug in y equals 0. That means 5x minus 2 times 0, because we know y is 0, equals 20. That means 5x equals 20 divided by 5. Excellent, guys. You got the correct answer. X equals 4. Or the point is at 4, 0. If you are interested on the point. If you say x equals 4 and you go to the x-axis and locate 4, that's perfectly fine. So this is the x-intercept. Now for the y-intercept, x is 0, so you have 5 times 0 minus 2y equals 20. So this is 0, negative 2y equals 20, divided by negative 2, divided by negative 2, y equals negative 10. Excellent. Most of you got this one also right. So y equals negative 8 is right here on the y-axis, or x0, y negative 10 is the y-intercept. So we have now 2 points. All you have to do is just connect those 2 points and you are done with your graph. That's how simple graphing is, if you know x-intercept and y-intercept. Any questions so far? Any question? Okay, if you don't have any question, we'll go to finding slope and y-intercept, then used to graph the equation. So before that, let me explain one thing for you guys about slope-intercept form of the function. So before moving to the example, it's better to describe what we are going to do. Slope-intercept form. So if you have given a function y equals mx plus b, the number in front of x, or the m, is called the slope. So this is the form of the function which is called slope-intercept form. Y equals mx plus b. So the m is the slope, which is rise over run. So that tells you how much it goes up and down. Rise means going up and down. If it is positive, it goes up. If it's negative, it goes down. And run means it's always to move to the right or left. So in this case, it's always to the right. When the slope is negative, we go down, then still to the right. When the slope is positive, we go up and to the right. B is the y-intercept. Y-intercept. Because when x is 0, so if you see when x is 0, so you'll have y equals m times 0 plus b. So m times 0 is 0, so y equals b. So this is the y-intercept. Because x equals 0. So the y-intercept is always at b. So if you know the y-intercept, this is how you graph. First, locate the y-intercept. The y-intercept. So that's the first point. To find the second point, use the slope and go up and left, right, by using the slope. Use the rise over run to find the second point, which is rise over run to find the second point. Finally, number 3, connect the 2 points and you have your graph. Connect the 2 points. When you connect the 2 points, you have your graph. Okay, so now let's see examples. So we follow these 3 simple steps. Okay, now if you see this example, we have we compare this to y equals mx plus b. Tell me what is b, what is m. So b equals how much and m equals how much. Write in the chat. Just a number. So b and m are numbers without a variable. So you have to drop the x. Okay. Let's see. Okay, good. So we have, you transpose them. Here you go. You get the numbers right, but you change them. Just look at the 2 equations. Y equals negative 3x plus 2 and y equals mx plus b. So let me circle it for you guys so that you can see what I'm talking about. So do you guys see this? Do you guys see this? Excellent. You got the numbers right, but you just transpose them. So m is negative 3. B is 2. So b equals 2 is right here, the y-intercept. So when you see b equals 2, that means it is on the y-axis. Now, using m, we find the second point. This is how we find by using m. So we know m is rise over run. Now, m is negative 3. That means it is negative 3 over, change it into fraction by dividing by 1. If you have a whole number, divide it by 1 to change it into fraction. So now if you see it is negative 3, that means it goes down by 3, then over 1. Over 1 means to the right by 1. So you go down by 3. So you go 1, 2, 3 down, and 1 over here. So that's the second point. And that's how we find the second point, by using the slope. If m is positive, it goes up, not down, okay? So this is the slope of the line. So I want you to pay attention. When the slope is negative, it goes this way. So downhill, negative slope. Uphill, if it goes this way, it is positive slope. Okay. Now do the same thing. Y equals mx plus b. Find m, find b, and we'll discuss about this. So locate b first. After that, find the second point. So give me the second point. So answer 3 things. 1, m, then b. Once you have m and b, find the second point. So give me the order pair for the second point. Yeah, y equals 2, x minus 3. The slope is negative 3. M is negative 3. That's not y, x and y. It's m and b. Slope and y-intercept. Okay, now for the next one, find b, find m, use b, start from b, then use m, and figure out the second point. You guys tell me M and B, just M and B. What is M? What is B? Yeah. 3/4, excellent. And what is B? So M is 3/4, the number in front of X, and B is -2. Yeah. So M is rise over run. So rise, that means up by 3 and over 4. So you have -2 for B. So you start from -2. So once you find B, that's the first point, -2. So it says 3/4. That means it goes up by 3. You have 1, 2, 3 over 4. You have 1, 2, 3, 4. That's the second point, which is at 4,1. The second point is at 4,1. So you connect the two, that's your graph. Okay, that's how you graph the function. Now in the next slide, I'll show you how to change the standard form of the linear function into slope-intercept form. So if you are given a function like this, you can change it into slope-intercept form. So the way we do it is, because the function is in slope-intercept form is y equals mx plus b. Now the x term should be on the right-hand side. So automatically I have to subtract 5x from both sides. Okay. That's how you start. So this cancels out. So I have -2y equals -5x plus 20. Then divide both sides by -2. Each by -2. So divide this by -2, divide this by -2. Oh, sorry, this is 40, not 20. Sorry, that's 40. I've changed it into 20. Let's change it into 20. So sorry, give me a moment, because 40 is big number. So let's work with this relatively small number. Oh, give me a moment. Oh, sure. So we change the number to 20. Okay, it doesn't matter, but it can be 40, but it's better to work with relatively smaller number. Oh, my PowerPoint is not responding. Sorry, guys. Okay, so let's change this to 20. Okay, that's fine. So what you do is just subtract 5x from both sides. So you will have -5x plus 20. Okay, then divide each one of them by -2. So because we want to isolate y, so the y has to be by itself. So we divide each by -2. That way you have y by itself on one side. So y equals -5 over -2 is 5/2 x, and 20 divided by -2 is -10. Now if you see here, b is, so that's the equation in slope intercept form. So we can change it from the standard form into slope-intercept form. B equals -10. So we have -10 here. Then it says M equals 5/2. That means it goes up by 5 and over 2. So you go up by 5, so you have 1, 2, 3, 4, 5, then over 2. Again, you go up by 5 over 2. You can continue doing that until you get more points if you want. 1, 2, 3, 4, 5 over 2. I was counting. So you have 1, 2, 3, 4, 5 over 2. Again, 1, 2, 3, 4, 5 over 2, like that. So it's going this way. 5 over 2, 5 over 2. So you go up by 5, then over 2. That's how you graph standard form. You can use the x-intercept, y-intercept and graph it, but you have to know how to change from this form to this form. Okay, that's the objective of this topic. I mean, this slide specifically, this slide. So changing from standard form into slope-intercept form, then you find the y-intercept and the slope and you graph the function. You don't need more points, you need only 2 points, okay? So the same applies here. I want you to give me M and B for the next one. What is M, what is B? (24 and 4). Okay, so B4 is right, but M is not right. Here you go, check it again. I think you forget to divide. So you divided 16 by 4. That's why you got B equals 4. So the M also should be divided. So when you divide each one of them. So excellent, you got B right. So check again the M. Oh, we have 1 minute, so yes, that's better. So you subtract 24 first, 24 from both sides, 24x. Subtract 24x. That means you have 4y equals -24x plus 16. Then you have to divide each by 4. Don't forget to divide by 4. Okay, so when you divide each one of them because your objective is to isolate y. So this becomes -6. So technically it's -6/1 x plus 4. So it is -6/1, which means it goes down by 6 over 1. And you have b equals 4. So you go to 4, you go down by 6, you have 1, 2, 3, 4, 5, 6 over 1. Down by 6 over 1, like that. So keep doing that, down, up by 6 over 1. So it goes like that. So the graph goes like that. So that's your final graph. Okay, it's exactly 7:20. Do you guys have any question? I know we studied a lot of stuff. So so for this topics, I will extend your due dates for the assignment and the quiz because we covered a lot of stuff. And I know it looks the problems look simple when we do it together, but when you go and study, it may be challenging. So for that, I want to give you time so that you can process it, work on it. If you have any question, I'll be available on Saturday, this Saturday, because you have exam next week. So I'll be available on Saturday at 4, from 4 to 5. You can join me and can ask questions. Okay. Otherwise, this is the lesson for today, and I'll see you guys Tuesday. Bye-bye.